Okay, welcome to lesson 5.4. We're moving into the algebra part of this chapter, so my favorite part. Today we're going to look at solving rational equations, and then our next lesson is solving rational inequalities. So today equal signs, and then tomorrow like less than or greater than signs. In our warm-up today, I'm just going to remind you how to solve this example. So this is an example you would have seen in grade 9 math, where I do have some algebra, but all of my denominators here that I'm solving are numbers. So there's lots of different strategies, but I want to use the same strategy that I'm going to use with algebra to solve this, just to kind of get you thinking about that. So the very first thing that I would do to solve this equation is find the lowest common denominator. And that's probably similar to what most people would do no matter what method they were using. So to find the lowest common denominator, there's a couple of different strategies that you can use. I'm going to use the same strategy that I would use for algebra. So it's way overthinking it when it comes to numbers. But what you do in your head is you think about the first denominator, 4, and you break that down to its prime factorization. So you factor it as far as it can go, is basically what that means. So when you do that, you get 2 times 2. And I can't divide 2 into 2 more numbers because it's prime, right? So I've got 2 prime numbers here. And what this tells me is that my lowest common denominator needs to have at least 2 2's. And then I look at my second denominator, 6. And the 6, when I do the prime factorization, 6 is the same as 2 times 3. And now those guys are both prime numbers, so I know I'm done. And that tells me that my lowest common denominator needs at least 1 2 and at least 1 3. And this is an and. So when I come up with my lowest common denominator, I have to have at least 2 2's. So I know I've got to have 2 2's. And then this one says you got to have at least 1 2. Well, I already have that, so I'm not going to repeat myself. And at least 1 3. I don't have that yet, so I'll tack on an extra 3. So it tells me my lowest common denominator is 12. So you know that some people would look at this and do 4 times 6 and get 24, right? And 24 is a common denominator at work, but we want the lowest. And this is really this kind of what you're going through in your head, but you guys do it much faster with numbers. We're going to do the same idea though with algebra in this chapter. So now that I've got my lowest common denominator, there's a couple of different things you can do with it. But when we work with algebra, what I'm going to do is actually multiply every single term by that lowest common denominator, 12. So I'm going to do 12 times the first term, and then I'm going to do 12 times the second term. Now you can leave the negative with the 5x minus 6 if you want, or you know that it's going to be a negative at some point, right? Because I've got positive 12 times a negative term, so I'm just going to pull the negative out. And then I left myself tons of space. And then I'm going to do 12 times the last term. So don't forget about this guy over here. Even though he's not a fraction, I have to multiply him by 12. So my second step here, I think I actually have this written on the other page. But it's the same process that I'm going to use for my algebra. So now what I'm going to do is cancel, and I should be able to cancel away all of the denominators. So what I do is I look at my lowest common denominator that I've multiplied by and my denominator, and I'm going to actually just divide those two numbers. So 12 divided by 4, that's the same as 3 over 1. And then 12 divided by 6, that's the same as 2 over 1. And it's always going to work out that I'm going to end up with all of these 1's on the bottom, so I have no denominators at all anymore. So now what I have is 3 times x plus 1 and minus 2 times 5x and then negative 36. And now I can just solve this polynomial. And so now I'm just going to collect my like terms. I'm going to bring the positive 3 over and subtract it from the other side, and then I just divide that out. I've got a negative divided by a negative, that turns into a positive, and it's 39/7. So my third step there was I canceled the common factors, and it's the same thing we're going to do with algebra. And that got rid of my denominators, and then I just had to solve the polynomial. And again, I think I have these steps written on the other page. All right, so there's our warm-up. That's a grade 9 question because it had just numbers in the denominators. Now we're going to ramp it up, put some algebra all the way through. So, solving rational equations. Strategy 1 is a little bit simpler than what I just went through. Strategy 1 only works, though, if I have a fraction equals a fraction, or if I have a fraction equals a number, because remember, a number is just a fraction, so it's really just the same thing. So if I have one of these two cases, I can use the strategy of cross-multiplying and then just expanding and solving the polynomial equation. It's a little bit simpler than the other strategy where you had to come up with the lowest common denominator. So, and then don't forget to state restrictions. I usually tend to do this from as soon as I can, like from the beginning, because I forget if I don't do it. So I'm going to do it right now because I swear I'll forget even at the end of this example. So stating restrictions. Now restrictions are what can't I put in, what values for x are not allowed. And that always comes from the denominator can't equal 0. So in this case, there's only one denominator for me to worry about. Some equations that I start with are going to have two denominators. So what I have is this whole polynomial can't equal 0. So to come up with what are the x numbers for that, I'm going to factor the left-hand side, and it's going to tell me what I can't have. So here, what multiplies to -3 and adds to positive 2. So x plus 3 and x minus 1. Remember, simple trinomial, you don't have to go through decomposition. So that tells me that neither one of those brackets can equal 0, or the whole thing would equal 0. So that tells me that I can't put in a -3 because that would make this bracket equal 0, and I can't put in a positive 1 because that would make that bracket equal 0. So there's my restrictions. X cannot equal these things. I'm just going to put a box around it so it stands out in my work. And now we're going to go and actually solve the equation, realizing that neither one of these can be answers. If I come up with one of these answers at the end, I will have to eliminate it from my solution set. All right, so we're going to use our cross multiplication strategy because I have a fraction is equal to the number 2. So all I'm going to do is take this denominator and multiply it up to the other side. You might not even be thinking about that as cross multiplication. Maybe you're thinking about it as like rearranging an equation. And now I just have a polynomial to solve. So I'm just going to expand the 2 into this bracket. And now I'm going to collect all my terms on one side. Because I have a polynomial, I have an exponent bigger than 1 on my x's. I need to get 0 on one side. Oops. So I had I had 2x cubed. I've got minus 2x squared, and I'm going to subtract another 2x squareds. And then I've got minus 4x. I'm going to subtract another 4x, so that's minus 8x. And then bringing the -6 over, that's plus 6. All right. And now what I notice is that there's a common factor of 2. And you're not going to like this, guys. I've got here a cubic polynomial, and I can't use factoring by grouping. That would be my only method here, other than the factor theorem in long division. So I am going to use the factor theorem. So I'm going to say let f of x equal the polynomial that I'm trying to factor. And you missed long division, right? Now we're going to try and find numbers that I can plug in here that make the whole thing equal to 0. So you might try like f at 1 or f at -1. Remember, we usually look at this constant at the end and find factors of that. You're going to find that f at 3 works. And what that tells you, don't forget to explain what that means. That means that x minus 3 is a factor. And then we can go through our long division process. Remember, if there was a term missing, I would put a placeholder like a 0x or something if there was no x term. And now I ask myself, x times what would give me x cubed? And it's x squared. And then I just multiply the x squared through the divisor. So x squared times x gives me x cubed, and x squared times -3 gives me -3x squared. And now I'm going to subtract. So x cubed minus x cubed gives me 0 x cubes. And negative 2, remember I'm subtracting the 3, so it's adding 3. And so I'm left with 1 x squared. And then I bring down the next term. Now I'm going to do x times what will give me x squared. So that's positive x. And I get x squared minus 3x. When I multiply the x through the divisor, and then I'm going to subtract. Again, these two should always cancel away to 0. Then I've got negative 4 subtracting negative 3, so adding 3, so I've got negative x, and then bringing down the next term plus 3, and then x times what will give me negative x, oops, x times what will give me negative x, negative 1, and then I multiply the negative 1 through the divisor again, and it should work out that you get 0 here. Otherwise, something went wrong. Maybe you did a calculation wrong here, or something wrong in the long division. So now what we have, going back to my original equation here, is I have 2 times, and instead of writing out the cubic like this, I'm going to write it as the divisor x minus 3 times what we came up with here, equals 0. You can divide out the 2 on both sides and it will disappear on you. It doesn't hurt though to leave it there as well. It's not going to give you solutions, right? 2 is never going to make, like multiplying by 2 will never make something equal to 0. Either this equals 0 or this equals 0. I'm going to think about trying to factor this guy, what multiplies to negative 1 and adds to positive 1. And there are no factors, which tells me that to solve this, I actually have to use the quadratic formula. So don't forget, this guy here gives you the solution, x equals 3. And then for this one here, we're going to use the quadratic formula. So x is equal to negative b, so negative 1, plus or minus the square root of b squared, so 1 squared, minus 4 times the a coefficient, that's 1, times c, that's negative 1, all over 2a. Oops. A is 1. All right, and then we can simplify this. This comes out to negative 1 plus or minus, and underneath the square root here we get 1, and then it's negative 4 times negative 1, so that's plus 4. 1 plus 4 is 5. Oops. And then that's all over 2. Now you can change those into 2 decimals, but I actually prefer it in the exact form. So I'm just going to write my solution set. Therefore, x belongs to the set of either negative 1 plus or minus root 5, all divided by 2, or 3. And I did just glance up at my restrictions. Remember your restrictions where x can't be negative 3 or 1, and we haven't broken that rule here. So we're okay. All right, our next example, part B here, again, we're starting with a fraction is equal to a fraction. So I'm going to use that cross multiplication method. Remember when I cross multiply, I take the numerator on one side and multiply it with the denominator on the other side. And then I do the other numerator times the other denominator. Again, if you're like me and you're afraid you're going to forget restrictions, do it now. I just get so excited about my solutions that I forget to go back. For my restrictions, I have to make sure that neither one of my denominators equals 0. So you can start by just writing those down and then solving each one. And I'm okay when they're simple like this. If you want to go right to the restriction, that's fine. So I've got my 2 restrictions, and now I'm going to come back here and keep solving this. So now I have some polynomials to expand. And then here I'm going to do x times x times negative 1, then 2 times x, and 2 times 1. And I'm okay if you can expand and collect those middle terms at the same time and just end up with this, that's fine. And now I'm going to collect all my terms on one side because I have a squared, right? I'm going to get 0 on one side, and I'm going to move the 4x and the 2 over. So here I'm going to add the 2 to this side, and it's actually going to come out to plus 0 at the end. You can write that, but you don't have to. Now this becomes much easier for me to factor and solve. There's a common factor of x, And I'm done. I just now have to solve each one of these factors, set them equal to 0. So either x equals 0 or x equals 3. And again, if you want to write x minus 3 equals 0 and then rearrange, that's fine. So therefore, I've got my solution set that x belongs to the set of 0 and 3, and I've double checked here that I haven't broken any rules with my restrictions. All right, strategy 2. So this one I have to do when I've got like an addition or a subtraction of fractions. Okay, this can also replace strategy 1, so this strategy always works, it's just harder. The first thing I need to do is find my lowest common denominator. So to do that, you do want to factor the denominators first. In this case here, I've got 3 denominators, x minus 3, and then x, and then another x minus 3. So mine are actually already factored. So remember in the warm-up, I looked at each of the 3 denominators. So my first denominator is x minus 3. There's only that one factor, so I need at least 1. My second denominator is x, so I need at least 1. And my third denominator is x minus 3, so I need at least 1. So when I come up with my lowest common denominator, I just start with like listing out the first one, x minus 3. Then I move to the second one. Do I have at least one x factor? Well, no, I don't. Remember, this is like x minus 0, right? That's not the same as this. So I need an x factor. And then I get to number 3, and it says you need at least one x minus 3. Well, I already have one, so I'm not going to repeat myself. Don't add a second one. That would no longer be the lowest common denominator. So here's my lowest common denominator. I'm going to use it and multiply every term by my lowest common denominators. I'm so afraid I'm going to forget restrictions. I'm just going to slide down here and make a little note for myself so that I don't. Okay, so what I'm going to do is multiply every single term. There are 3 terms, 1, 2, and 3. So we'll do x minus 3 times x times the first term. Then plus, we'll do our lowest common denominator again, times second. And you could have rewritten this as like this to make it a little bit cleaner. But I'll just keep going because that's what I've done. And then don't forget the third term. I also need to multiply it by my lowest common denominator. And now, here's where the magic happens. Don't forget to do this. This is where we're going to start to cancel out our common factors. So I'm looking at that denominator, and there should be a common factor for me to cancel in my lowest common denominator. That's going to cancel away. And then I move to my second one. Look at the denominator x, and there should be one to cancel. If there isn't, then you chose your lowest common denominator wrong. And now all my denominators are gone. And I can just write what's left. So I've got x times 4, and then here I've got 1 times this bracket. So if there was like a 5 or something there, I would have to expand that in to the bracket. And then here I've got x times x minus 1. So there I've got some expanding to do. I'm going to do x multiplied by everything in the bracket, and then over here I've got 4x plus 1x, that's 5x, and then I've got 1 times negative 3, that's just minus 3. And again, I'm left with a quadratic, so I do need to get everything over to one side. I'm going to bring the 5x over and subtract it. Oops, I missed the other x there. So I'm subtracting the 5x, but there's already an x there for me to subtract, so minus 6x, and then I'll add the 3 over. All right, and this one again does not factor for me. There's nothing that multiplies to 3 and adds to negative 6. So to solve this, I'll use the quadratic formula. I'm just going to write it down here in case somebody needs it for their notes. And then I'll just plug in all my values. So negative b, so negative 6, that's just positive 6. Oh, I forgot my squared over here. Did you guys catch that? All right, don't forget the x equals as well, right? Don't forget, like, what are you actually solving when you come up with the quadratic formula? And then I'm going to simplify underneath the root here. I've got 36 minus 12, so that's 24, and all over 2. And of course I can simplify this. Let's move my little reminder over here. So using my simplification rules for roots, and the idea that if I'm dividing by 2, I'm dividing every term by 2. So here I've got 6 over 2 plus or minus, and I'm going to change root 24. Remember to change the root. I think about how can I rewrite this as a multiplication statement where one of the numbers is a perfect square. So I'm thinking about 24 and I'm going through like a list of perfect squares in my head, right? Like so 1 squared is not going to help me because it's not going to change anything. But I think about 2 squared and 3 squared and 4 squared, something about like 4 and 9 and 16, and I can keep going, and I'm looking for which one of these divides 24. Well, 4 does. So I'm going to rewrite 24 as 4 times 6. And if there were ever 2 numbers that worked, you would always pick the bigger number. It's going to help you reduce it faster. And then 6 over 2, that's just 3. Over here, I can take the square root of 4, that's just 2, and then I'm just left with the square root of 6. So the square root of 4 times 6 is the same as 2 root 6, all over 2. But then, oh, what do you know? You got a common factor of 2 on top and bottom. You can cancel those out. And then we're just left with 3 plus or minus root 6. So my solution set, I think, is 3 plus or minus root 6, but I'm going to take a look at my restrictions before I decide that I'm actually right there. So for restrictions, I go back and I look at my original denominators. So I have x minus 3, x, and x minus 3. I'm not going to repeat my work. I'm just going to check out that the first one can't equal 0 and the second one equals 0, can't equal 0. So that one's already solved. This just tells me x can't be 3, and neither one of these are those. So therefore, I still need the set brackets because there are actually 2 numbers in here. And then I'll say that x can't be 0 or 3. And I'm all done that question. I hope you guys enjoy this homework.